Over to you, Michael.
Okay, so I'm Michael Rudgyard, I'm the CTO of Concurrent Thinking. So we're a spin-out company at the University of Warwick. Been around in various forms for the last 12 years, but this is our latest venture, so it kind of spun out of another company I founded. I got invited to this event because I've been talking to Rob for some time and working with a number of universities now on different aspects of looking at the total cost of ownership of their IT estate. So I'm going to talk today about data center compute and overhead costs and delivering what I call end-to-end key performance indicators. So I'll try to keep it non-commercial, but I have to give you some background about the company, so excuse me if I veer into commercialities here. So my background is high-performance computing and scale-out computing, and the product I'm about to talk about was originally developed to monitor high-performance computing systems, but we saw an opportunity to take it into what's called the data center infrastructure management space to look at the total costs in data centers. So we've been, in its current form, we've been going since 2010. We've had investment from the Carbon Trust. We currently hold a very large grant from the Department of Energy and Climate Change, and actually are using that grant to work with a number of universities to get some interesting information for both parties. So the real problem in data centers is actually rarely do the different stakeholders talk to each other properly. So you've got the kind of procurement people procuring in the blind. With respect to procurement people, I'll talk about that later on. You've got people who run the data centers saying it's all about their cooling overheads and the overheads of keeping the IT equipment going. You've got all of the IT team saying it's all about virtualization, and possibly you've got people saying we need to be more efficient with our staff resource and so on. But rarely are these guys really sharing information, which means often virtualization is done independently from looking at the data center plan in terms of cooling and overheads, and in most cases procurement is done with very little understanding of how the IT is used already, and that may help you avoid procuring, or make you help. If you knew more about it may help you to procure better. So what we do is really monitor all of the equipment in the data center, from building information systems, so systems telling you about power, environmentals in the data center, detailed environmental measurements at the rack level, power at the distribution board, rack PDU, and even the server level. Then we look at the IT equipment as well. Is it healthy? Is it operating at good temperatures, etc., etc.? But we also pick up information for operating systems and virtual machines, as well as applications. So I'll talk about how I bring that information together to create some useful information later on. So we do this by leveraging a number of standards. I guess people here aren't too technical, but excuse me if I am. Yes, I'm not giving you the benefit of the doubt on that one, but we leverage a number of open standards to get the information. So the idea is to try to understand where operational savings can be made through data, collecting data and understand the issues you have already. You also need to understand how factors vary over time. So, for example, you may find that some computing systems are used much more certain times of year than other times of year. Even at the end of the week, I mean, sometimes the finances systems only roll up at the end of the month when they run payroll and sitting there idle for the rest of the month. So it's important to understand the historical changes of utilisation, etc. But it's also important to have monitoring in place just to give you ample warning of potential, often critical issues. So it's amazing how, and I have to say in the university space, how little monitoring goes on in data centres already, even to avoid potential outages. But a key aspect, I think, which is relevant to this grouping is all about reporting factual information to management that allows them to make rational choices and helps the data center manager and the universities drive what we call continuous iterative improvement. So you improve your cooling, and then you improve your virtual machines, then you improve your cooling again, and so on. So it's a kind of virtuous circle. That's what we're pushing for. Further down the line, in fact, as part of the grant we have with the Department of Energy and Climate Change, we're looking to implement capabilities with our product to do more automation within the data center. So you can start thinking about, well, if I control the cooling systems and I control virtual machine migration, for example, can I automatically move virtual machines around the data center whilst turning air conditioning units off in the middle of the summer when utilization's down and so on? So that's where it's heading, and a lot of people talking about the autonomous data center. I think we're a few years away from that in practical terms, but we try to look forward a bit. So our approach is we're providing people a tool, and it really is a tool, because at the moment we're not the software doesn't do proactive changes because most people would deem that too risky in a data center environment. It can do some proactive stuff as well, so I shouldn't say it does none, but generally it's really all about monitoring things. So it's about monitoring power to the server, network, OS, VM and application level. I'll talk about this later on. We can report by department, customer or end user, so you can do things like set up groups. So some servers are owned by different groups of individuals, different academic groups, different groups with different departments within the university, and it allows you to start reporting by group. We do integrated asset management, and that's quite important for some of the things we'll talk about. But really, one of the areas we want to push more is more about the business intelligence, trying to give people proper feedback on the cost of service. So again, I don't know how many people here are aware of the different KPIs that have been pushed forward by various data center groups. The key performance metric in terms of data center performance that's used the most is something called PUE, power utilization effectiveness, which is really about how efficiently you're cooling your data center. And the issue there is you could be cooling your data. You could have the most efficient cooling system on the planet, but if your servers are there doing nothing, you've got the most inefficient data center on the planet. And there's various other metrics that people have put forward. But what we try to do is allow the user to define what KPIs are important for him. And those could be just the cooling, just PUE, cooling overheads. But you could actually look at the end utilization of your servers. So, for example, you might want to look at something I've called the compute utilization effectiveness. So, essentially, how many, CPU cycles per watt or something like that. You might want to look at network, you might want to look at storage, and you might want to draw yourself a spider graph to see how efficient you are on a number of measures. What I'll talk a bit more about in a second is the real metric you might be interested in is the cost per service. So if you have an email service, you might want to know the cost per 100 emails of delivering those emails. You might want to know the CO2, you might want to know the power taken. So one of the most interesting metrics in terms of generality and simplicity is, as I mentioned before, OS performance monitoring. So the idea here is that you want to get figures like CPU utilization per watt. Okay? Now, CPU utilization per watt in itself may not be very useful because different CPUs can deliver different amounts of work. So what I would suggest is you rationalize that by some benchmark of the CPU. So if this CPU is 10 times more powerful than the other CPU, you're looking at a biased CPU utilization by watt figure. Again, you could look at IOPS per watt, looking at how efficiently your storage equipment is working, or bytes per watt if you're looking at network equipment. So in our tool, to get these metrics, what we're doing is we're monitoring different aspects of the data center and combining them all together in a single metric. So we're monitoring the operating system's metrics by SNMP on Linux or Microsoft systems, or using something called WMI, the Windows Management Interface on Windows systems. Then we look at the server power utilization. So if you've got a managed PDU, so if the server's plugged into a managed PDU, we track the power from the managed PDU to the server. If you've got a modern server, then actually most modern servers you can get the power draw directly from the server or the blade enclosure. Then we look at a CPU benchmark figure just for normalization purposes if necessary. Then we look at the power overhead for cooling and power distribution. So how much power is going into your PUE figure, if you like. And then you may have power costs that change over different times of day. So, evening you may be paying 9 pence per kilowatt hour. In the middle of the day you may be paying 12 pence per kilowatt hour, so you have to bind that into the computation. So essentially by monitoring all of these things, so you can see how we're kind of traversing all the layers from the data center, going from power distribution and cooling all the way down to an application, operating systems. And from that we can get these performance metrics. And we've demonstrated that. Are you talking about that at all? No. The CPU utilization per watt, I guess you didn't implement.
I've got similar kind of
thing. Fine. As another example, what we looked at was Microsoft Exchange. And again, the utilisation figures here of interest may be power usage per email, cost per email, or CO2 emissions per email. And once again, it's quite easy to get this information if you have a tool. You can use the Windows management information, and Microsoft Exchange tells you the number of email transactions or the number of various whatever transactions you're interested in. So then we looked at the number of email transactions, the server power usage, the power overhead, the power cost, the asset depreciation model, if you're looking at OPEX and OPEX versus CAPEX. So let me explain that in a bit more detail. When you look at the end-to-end cost of delivering a service, there's an OPEX cost and there's a CAPEX cost. And one of the things that most people aren't aware of is when does it make sense to continue running a server on continue running an application on a given server. So typically, the finance people buy servers and they want you to sweat the asset. But a 3-year-old server is a very inefficient beast. But no one has the information to know, when do I swap out a server? The IT manager always wants to buy new servers. The finance manager never wants to buy new servers. And there's a lack of evidence of when to do that. In our case, what's possible is you can define an OPEX. You know your OPEX because you know power. So I'll take staff out of this, but you certainly know power. Power costs and power overhead costs. You may have a depreciation model, you know how much the server costs, you know how many months you depreciate it over. So, and your own FD can define a depreciation model that works for you. You can plug that into a calculation and work out when it makes sense to swap out a server based on the fact that this new server is delivering 20 times more emails than this old server. So it's possible to do that as well. So we've just got some pictures here of how the kind of results we got. This is just an example in implementation where we're actually getting figures out, cost per emails and so on. Another example that we did was looking at MySQL. Again, if you've got databases in there, this could have been Oracle. It's very easy to get information from the database. With Oracle, you can do it from SNMP, and in fact, MySQL also has an SNMP MIB that allows you to get information on the number of transactions that database is offering. Okay. So, following the same kind of thing that I talked about earlier, it's possible to get an end-to-end cost per database query. Okay. The last one we've looked at up to date is Linux Apache. So if you've got web servers, it's possible to configure Apache so that it gives you the number of HTML queries. And following the same argument, it's easy to get cost per HTML query. Apache was a bit more difficult because the SNMP support for Apache was pretty poor. But what they do is provide a really nice web interface that tells you the number of transactions that Apache server is giving you. So we just queried that web interface to get the number of transactions per minute and so on. So I've given some examples of actually application performance per watt and why this might be interesting. Another thing that we looked at then is, okay, so what if you virtualize your applications? How can you then kind of get an understanding of how efficiently you're using your virtual machines? Well, one thing you don't have with the virtual machine is you don't know how much power it's drawing. Okay? But you do know you've got 4, 5, 6, 7, 10 virtual machines on a server, and you do know, hopefully, the power the server's drawing. So we've solved this problem by what we called inferred metrics. So what we do is essentially divide up the power of a server based on another metric that we can measure. So, for example, CPU utilization of each individual VM may allow you you can use CPU utilization as a proxy for power use. So you have a total power, you just divide it up by the total CPU. It may not be the best metric, but it's something you could do. It could be network I/O, it could be a mixture of network, power, data.
So are you essentially saying that the power goes up and down with the amount of processing the machine does?
I mean, that's the kind of proxy we're using there, yes. I mean, it may be network traffic, so I'm not suggesting we have the best metric. I'm just saying that our tool allows you to configure it based on another proxy, and it could be several proxies. So if you do some experiments and find that this is a better proxy than CPU utilization, then it allows you to plug it. So once you've got this information, let's say you've got information on, let's say, CPU utilization per watt or performance per watt, it gives you a lot of power then to look at, for example, which servers are being underused or inefficient or should be virtualized. I mean, in our tool, you see every server, because we have a database of all of the servers. We know where the servers are in the rack. We can actually show you graphically which servers are performing and which are not performing well. Okay, these little bars are essentially showing you a measure of the KPI associated with that server or that application running on that server, and we can show the same thing for virtual machines. As I mentioned to, I think, you two beforehand, people think that once they've done the virtualization, they've solved the problem. But the reality is most people virtualize in the dark. They have no historical data on which they base their virtualization strategy. So they just virtualize on the basis that, well, I needed a server before to do this task, and now I've bought a new server that's 10 times more powerful. I'll put 10 virtual machines on there, which means your efficiency has just stayed the same. So it's kind of important to understand your utilization, your normalized utilization, before you virtualize.
Does it also help to inform how you group your VMs on a physical box? Because again, that tends to be in the dark as well.
Yes.
You think, there's some spare capacity on that one, I'll just throw it on there. There's no load balance.
And that's why you also need to know when your peaks, if you don't have historical information, you can't really make a decision on where to virtualize, because it may be that you virtualize all of the applications that work really hard on a Friday afternoon or something. And therefore that server is going to get really bogged down on a Friday afternoon because you looked at average utilization. Right? So because you've got all this historical data. I'm not saying it doesn't. It's not presented to you like do this. You have to kind of look at the tool and look at the historical data and make decisions based on it. You may ask yourself which servers are better at delivering a particular service. So if you know emails per watt, and you've got two different types of servers, you might think, that one is a lot more efficient at delivering that service because of the network performance, because of its CPU performance. I mean, there's various reasons why that might be the case. You could actually turn it on its head and say which application gives better performance on the same hardware. So you want to compare MySQL versus Oracle, you could do that. And you could use either of those metrics to beat up your favorite supplier to say, why is your hardware not performing as well as his hardware, or vice versa. And as I mentioned before, the key thing is, when do I retire old servers? I know that in some data centers, Google replaces all its servers on an annual basis, just because the OPEX costs for Google outpace the CAPEX costs. Google happens to make a lot of its own servers or get them made by OEMs, so therefore it can, the CAPEX cost is relatively low. But I'm pretty sure that most people should be swapping their servers out before 3 years, and I know very few universities actually go on that kind of refresh cycle. 3, 4, 5 years is the average refresh cycle probably.
Yeah, what we do is you actually replace it when a box becomes a certain age. It might be performing perfectly adequately, but then it gets replaced over one that is maybe slightly younger but not performing very well.
Right, well. Yeah,
so it's actually driven by the wrong...
And I think the other issue as well is that, the average utilization figure apparently for data centers is between 5 and 10%. So CPU utilization is between 5 and 10%. Fully virtualized, the figures banded around a 10 and 15%. Now, the major problem you have with old servers is that when they're not doing anything, they tend to be burning a lot of electricity. So you can get some 3-4-year-old servers that will burn 90% of the electricity that they would burn if they were flat, if their CPUs were flat out. So that's something that people don't take into account. So the other thing you can do is start reporting on IT efficiency or power utilization by department. So we can set up different widgets to allow you to look at departments. And again, this is something that the Carbon Trust said to us, some of their consultants said to us, measuring power is not enough. You've got to demonstrate who's the bad person. You've got to use a carrot and stick approach, because the reality is that most data centers are only providing the service. A lot of them aren't empowered to go and turn people's servers off and so on. But unless you're reporting back to the department saying, how come you as a department are 5 times worse than this other department, there's no kind of competition. So I'll finish with some conclusions now. So it's actually more straightforward than people think to monitor certain key KPIs for data centres, as I say, even if it's just PUE, ITUE, or application utilisation efficiency. It does require you to have a proper tool in place, and it does require you, my belief, to have asset management as part of that, because you know something about the hardware it's working on to make some of the decisions I mentioned. You probably need to be able to monitor power on a fairly fine-grained level, and unfortunately that's not available at most universities that I'm aware of. People have not invested in that, but it perhaps is certainly, as I say, modern servers have that capability built into the server, but it would certainly allow you to make sensible decisions moving forward. And of course it does require some configuration, so I'm not suggesting that if you're running 500 applications in your data center, it's worthwhile going down to the level of detail that I mentioned in terms of application performance per watt for each of those 500 services, but it might be useful to pick your top 10 services and go to that level.
Sorry, Michael, you're finishing off.
Yeah.
Just got a thought when you finish.
Okay, fine. And once again, you want to be able to apportion costs by rack, servers, and department. We believe that the ROI can be very significant, and from what we've been doing with a number of universities, we can see that it's quite significant. The potential ROI can be quite significant, even down to not building a new data centre, which is a very significant. One of the real challenges, I guess, which is so I've really talked about now monitoring applications where you have a single application for a particular end user. Things get slightly more complicated when you have a single application that's shared between many end users, and of course monitoring and dividing up costs at that level is a bit more complex. It's doable. And it really depends on the information that the application provides in terms of who's accessing the application. And I think Stephen's going to talk about some of that next. From our perspective, we like working with universities because they're a good proving ground for technology, and they are more interested in a more research-based approach than some of the corporate data centres. So I'm happy to talk to you guys. We've got ongoing collaborations with Stephen here at Hertfordshire, and we're doing quite a lot of work with Surrey University, actually, ensuring that their data centre is extremely efficient. We're also working with a few HPC centres, so HPC Wales and STFC Daresbury. We're looking at the efficiency of their HPC resources, and in particular charging back power to their end users. And I guess from the university perspective, you kind of have a corporate IT section and a research IT, and I guess that point there is we're dealing with both to some extent. As I say, my background's HPC, so I know that fairly well. Thank you.
And the presentation will be available afterwards.
Yeah, all these will be available afterwards.
And I should say, without being too commercial, is that the current Department of Energy and Climate Change grant that we have, part of that allows us to work with end users to get some white papers out that are good for the community and good for the company. So if there's funding available for our staff to go and do that. So if there's any interest in doing so, we'll be happy to.
Sounds like you and I should have
Yeah.
What I'm going to talk to you about this afternoon is a project that we undertook at the university to look more into what it actually costs to deliver services in real time from our data centre. So I'm going to go through today what the business drivers were for us undertaking the project itself, some of the kind of challenges that we came across, which were varied and not quite what we expected, and I think I echo Heidi's comment earlier that some of this is easier to talk about than it is to do, particularly if you're trying to do it retrospectively. So I think there's a lesson to be learnt there, that's for sure. Learning that came out of the project and some of the outcomes, and obviously just sum up some of the things that we've seen in the presentation. Okay. I'm going to go through this in about 20 minutes, so which should leave us about 10 minutes at the end for questions of myself and Michael. So, okay, so the reason for undertaking the project, well, we have a couple of University of Hertfordshire initiatives. One is a carbon management plan, and that was to reduce our carbon footprint by 43% by 2020, based on 2005-06 levels. And also we have key performance indicators for sustainability, And underlying that, we've got a green ICT strategy, actually, which I manage for the university as well. So there's doing lots of good stuff in there to do with power down of PCs and reducing the number of printers we have and power down of AV and that kind of thing. Okay, so not just efficient data centres, although I've got a big part in that as well. And of course, there's FK encouragement to reduce our carbon footprint. You know, some of the funding they provide is based on reducing our carbon footprint. And just, you know, from an operational perspective, we want to reduce the cost it takes to deliver our services. And we've wondered whether this might be able to give us some information to help us do that. And essentially making the best of the scarce resources that we have. Now, we don't pay the energy bill within the university because I'm the IT department, but you know, that doesn't mean that we don't want to reduce the cost of running the university so that the whole university benefits. And we've shown some good gains in terms of what we've saved and what we can put back into teaching and learning. A big question that comes with certainly from our senior executives is, you know, should we be doing this at all? Should we be delivering services from our own data centre? Should we be going out to the cloud? And of course the answer is we don't really have that information. And so we've got plenty of data, which I'm going to demonstrate to you. We can get data out, but it's putting that together that makes sense so that we can actually go and make that actual assessment. And there's no framework that we can actually turn to, which is why we worked with JISC. You know, JISC has funded us so that we can provide that framework. So if other institutions want to do what we've been doing and work out the cost of delivering services. And this fits quite neatly into, you know, Heidi said she doesn't know how to cost the operational side of her model. Well, this is exactly what we're doing. So that fit quite neatly into her model. Now, the data centres at the University of Hertfordshire are consuming somewhere around 1.7 gigawatt hours a year, which equates to somewhere between 2 to 4% of the electricity bill for the estate, which is a significant amount of money. And the question I have as a data centre manager is, well, what's contributing towards that cost? I mean, I work out the PUE, the power usage effectiveness for my data centre, so I know what the plant costs, and I know what the IT load is. But what's driving the IT load? Is it a particular set of services? Is it an individual service? Is it just very general across them all? And it's when you start to ask those kind of questions, you realise you don't have the answers. And another thing is, you know, can our service users help us to reduce the cost in the way that they use the systems? You know, and again, don't want to make this sound like a nirvana for all your costing issues and operational efficiencies, but you know, certainly this can provide that kind of data to allow you to make those kind of assessments. And then looking forwards, you know, what kind of capacity do we need for our future data centre? Again, you know, this is a step along that path to having all that information to hand. So the project was 12-month project. Actually ran a little bit longer than that because I had a baby in between, so I had to extend it out a few months. I'm afraid.
You're looking remarkably well on.
I know.
You got your figure back very quickly.
I did.
He's not walking properly.
This is down the gym every night, you know. But and we've been working with Concurrent Thinking, who have been providing us with some of the expertise and the know-how to allow with us to get through some of the challenges that we had. The key point, though, on the project was we wanted to be able to use inexpensive hardware, and we wanted to be able to grab information from data that currently exists within our data centre. And most modern servers, I don't know if Michael mentioned this, but most modern servers provide all this kind of data. You just need to know where to get it. So once you've grabbed it, you can then make sense of it. We need to be able to measure power usage within systems and across hardware domains, because of course there's a lot of virtualization and consolidation that institutions are going through or have already been through. So it's not just a simple case anymore. You know, 20 years ago you could point at a box, put a power meter on it, say there we go, that's what it's consuming. It's got everything internal within it. Now that's not the case because we share resources across the data center. And then ultimately have a real-time environmental dashboard so that our senior managers can have say, oh look, this is what it costs to run this particular service, or this is what the profile looks like across the year, or whatever. So the specific aims and objectives, we wanted to build a model that gives us real-time financial and carbon costing, and be able to apply that model, if you like, to any service within the data centre on an as-needed basis or in totality. In reality, we're not going to do all of them at the same time, but we might want to point it at certain services. We also wanted to look at one of the tools that JISC promote, which is the SustIT carbon footprinting tool, and see whether we could build on that, make that more effective. And some interesting results that come out of that. We wanted to look at whether the information we managed to get out of the project could be used as a comparison for cloud services and the cost of cloud services. Obviously, we created a public blog because the journey there was quite interesting. So if you want to go and take a look and see the challenges we came across, they're there. And dissemination is an important part of running any JISC project. And also, we're quite happy to discuss this if any institution is interested in what we did and wants a few pointers as to how they might do it themselves. So, challenges. Well, as I say, a lot easier to talk about than it was to do. We wanted to start off quite simple. We wanted to say, well, have we got a system that is its own box? We could just kind of test everything out on and see whether we could do it. And of course, we've been so aggressive with our virtualization and consolidation, there was actually no such thing in our data center. The closest we had actually was a system that ran the library system, essentially, on its own, but it still shared disk in a SAN, and still obviously had shared network access. So that's about as simple as we could get. Another issue is that when it comes to determining how you're going to get that data, not all the systems behave the way you expect them to. And a lot of research needs to be done up front to work out whether you're actually going to get that data out. So you may think, oh, this system runs SNMP. And within SNMP there might be a power usage variable that I can tap. And then you find out that that's actually not supported on this modular server. So then you're stumped. You think, okay, I can't get it there, so I need to get it from somewhere else. And it's different for every server almost, for every model and range of computer manufacturer. Yeah. And they use SNMP uses things called MIBs to define the values that you can get out of SNMP. And again, I think sellers, vendors, when they provide you with a MIB for their device, I don't think they really put much attention into it because a lot of them had bugs or they had dependencies on other MIBs that might have a bug. Some of the variables that you wanted to get out, you couldn't get out of them because they weren't in the MIB, so you have to go and get them to produce you a special version that has those values. So it was really kind of complex, and we spent a lot of time just trying to get the values that we needed out of the system. And you have to be careful of things, because just because you've got a value doesn't mean you can trust it. So you need to double check that value. Particularly, I think there are things like rounding errors that you can get out of SNMP, which are a bit of a curse, actually. Communication protocols, well, I've talked about getting data out of servers, but of course if you're looking at a data center perspective, you're also looking at the plant. And a lot of the plant uses a protocol called Modbus, which isn't SNMP. So if you've got an SNMP system, you need to somehow convert between the two. There is such a device that exists, but we learnt that as we got into the project, and we had to go and buy that device. And DCIM products, Michael probably won't mind me saying so, but they are quite immature. It's a relatively new feature, if you like, within the data center, and a lot of different sellers of DCIM are coming from different directions. And some people in the industry might say, what DCIM is a solution that doesn't really have a question yet, a business question. And so a lot of DCIM vendors try to be all things to all men, which means that you end up with a product that sometimes you can get what you need from it, sometimes it requires quite a lot of configuration to get to where you need. Obviously I only have specific experience of Michael's product, but I have looked at some of the other products out there, and they all do things in different ways, and there are some false economies when you build a data center. You think you've prepared yourself for getting information out of your equipment, out of your plant, out of your servers, and then when you come to actually do it, you realise that you haven't paid enough, and there's some quite good lessons there. But the other thing is that your operational processes are also a big obstacle, and you need to be really careful, because if you want, for instance, you want to get power out of a particular server, and you can't get it from the server itself, so you want to go to the PDU. Well, if you haven't bought the right kind of PDU, you're probably just guessing, or if you haven't plugged it in correctly, then you're also guessing. You might need to make changes before then. So actually it comes down to even the way that you built your data center and the way you put your servers in. So there's lots of challenges as you go along, and change management can kill your monitoring, of course, because you go ahead and you set it all up and it looks great. And then somebody comes along and swaps out the server, or moves the server from one rack to another, or plugs something else in to the same power source, or, God forbid, start using power over Ethernet, which is really difficult then to start dividing out what you're using from a power perspective, what you're using from a network perspective. And all your calculations go mad, because you didn't know about it, and your system can't possibly know that because you swapped the server out, you're now looking somewhere else or looking for something different. So, quite a few challenges there. So from a kind of the server perspective, we did look at the we couldn't get the power out of the server, so we had to go to the PDUs. But that was fairly straightforward, because we managed to read the PDUs that are inside the racks. They give you a power figure, so we managed to read that, and that's fine. When it came to the storage, how much storage we used, we actually came across one of these challenges that was discussed a bit really in Heidi's presentation. You need to make a few assumptions, otherwise, because I don't think it's even possible to make an really accurate apportionment of the usage of storage within a SAN. But you can make some assumptions, which get quite a long way there. So when we were looking at allocate the power cost from the SAN perspective, what we decided to do is take the ratio of the disk storage in use by the service against that allocated elsewhere, and add it to the ratio of unallocated storage that allocated to the service. Now that all sounds a bit like gobbledygook, but if this is your SAN, okay, and let's say of your storage area network, just in case anybody knows what SAN is, so of your storage, let's say that's your allocated amount, and this bit here is your unallocated amount, okay? And within this allocated amount, the particular service that you're trying to measure is perhaps using this bit at the bottom. Okay. So what I said was, okay, obviously we know the total power cost of the entire SAN, because we've measured that and it comes out at X. Okay, but we want to be quite specific and look at this particular service and what that's using. So we say, okay, well, there's an allocated amount here, so we'll measure that. Okay, And so we did. But then we also want to say, well, hold on a second, just by virtue of switching on this storage, we have a fixed cost, if you like, for switching it on. So there's a bit here, although this service isn't using this bit, which is unallocated, it's still got to contribute towards it. So we assume that this bit here, if you divide that by the number of services using the SAN, then there's a thin sliver here which you can charge back to the service itself. Okay. So that's basically what we did. So we took the allocated piece and we took the allocated piece. But furthermore, what we also did, because it starts to get complicated when you look at thin provisioning with SAN. And thin provisioning is where you say, the service owner comes to you and they say, well, I need 3 terabytes of storage for my application. And you've got a system that's got, say, 70. Oh, what's going on? You've got a system that's, say, got 70 terabytes. You say, well, 3 terabytes out of 70, I only need another, 20 odd services, and I'm out of storage. But a thin provision system will say, well, I'll give you 3, but you're only going to be using 500 gigabytes to start with, and I'll give you the rest as you need it. So it'll look like you've got 3 terabytes, but actually, what you're only getting what you actually need, and it will grow as you grow. So then you've got to say, well, okay, so I might have reserved 3 terabytes down here, but I'm actually only using 1 terabyte. So I look at within this allocated section, I actually look at this bit here as well, the bit I'm actually using. Because that's my real, because this might actually be given to somebody else until I need it. So why am I trying to measure it against a service that isn't using it? Okay.
The technology can actually make things much more difficult, because Heidi was talking about costing out different tiers of storage, but the storage solution that we've got does dynamic tiering based on whether the files are or blocks are being used. They get moved up or down the tier to try and get the most efficient use of tier 1 versus tier 2 and 3. So it's going to be very, very hard to cost that up. You're going to have to use some kind of averaging method.
You are, and the difficulty is that a lot of the storage providers don't give you access into the internals. So you can't get the data. If you buy their management device, it will show you, where this service is using this particular tier of storage, or this particular tier of storage, or this allocated, this unallocated. And that's great, but getting that information out into a third-party DCIM product is really, really difficult unless you're willing to pay that vendor to do that work for you, the integration work for you. That becomes very expensive. I mean, we've got HP EVAs, and Hewlett-Packard, they have their own proprietary management interface, and you just can't get into it. So you forget it. And you can try and get into the switches and look at the throughput of storage, but it's so complex. And you start to ask yourself, is it worth doing? So you do have to kind of come to a point where you go, it's just not worth digging that deep. Why don't we make some assumptions? We're going to get a good sense of how much we're using and what the cost is, but is it really worth going any deeper?
Of course, you can just look from the server perspective, look at networking out the server and use that as it depends on the service, but if you just read and write the data to some shared storage, you can get that from the other side.
But that's assuming from the server you can separate out what you're using for storage and what you're using for ordinary network access. So are you rebooting, mate?
Yeah, I'll just reboot because I seem to be very unhappy about staying on the network.
There's such a big difference between, again, according to Heidi, the cost of providing tier 1 storage versus lower tiers. If you can't get that relatively accurate, then obviously you're going to then just average it out again, aren't you?
Yeah. And I think this works, the way I've done it, works best if your storage is separated out into its tiers. So if you've got a tier 1 set of storage, you've got a tier 2 set of storage, 3, and then you can put a power cost against each, and then you can decide, you can determine quite relatively, depending on the application, determine how much of each is being used.
I think I would, if I'm going to do hours at Solent, using the compelling technology, would just treat it almost as one tier, and then just look at all the other different things that aren't on compelling, like local storage or whatever differently, because otherwise it would just be so complicated.
And compelling uses thin provisioning as well, doesn't it? So when we didn't actually include in for this first phase of the project, we didn't include the network side of things because it just became so complex as to how do you divide the network up. You know, we could get the information from the switches, but you trying to determine, you know, it just wasn't worth it. But we are going to try and tackle it in a later stage, just from a kind of theoretical standpoint, I guess, and see whether it's practical to do it.
To ignore it completely would be wrong, but you've obviously got to keep, you know, an eye on the fact that what actual value you're getting out of spending lots of time gathering all the data, if it's not actually going to be that accurate in the end anyway. I
mean, there's still obviously power cost is very insignificant compared with server costs. I mean, switches don't really draw much.
Well, that's right, yeah. So although it costs you a lot in capital,
yeah,
the operational cost of running a network is actually quite low. So, you know, I reckon I'm probably plus or minus 5% from not including the network, you know, and it's probably not worth.
The value of learning from other people that have done it is to gain the experience of what things have they spent time on that's actually given them some real benefits, and what time have they wasted, for want of a better word, on things that actually didn't make that much difference. So you can concentrate your efforts on the things that are going to give you the biggest wins, and I think that's where we look to people that have already done it to prioritise the effort.
I mean, this is all kind of pretty advanced stuff, the kind of stuff we've been talking about today, and there's actually a lot of low-hanging fruit. I mean, in your case, you looked at the environmental overheads of the data centre and saved an enormous amount of money, you know, within the first few years, just by looking at that. Server utilisation is the next obvious one.
Because the one thing that strikes me when I go in the data centre, and we can call it that, computer room, is the fact it's very, very cold.
Yes.
Does it need to be that cold?
No.
Probably not.
Well, certainly
the fact
not.
that modern servers can operate at a much higher temperature than they used to be able to. Can I actually turn the cooling down by 3-4 degrees or whatever, or up, I suppose, and it doesn't make any effect on the, but it saves me an awful lot of money.
And the key thing there is you've got to, you know, obviously you're delivering a service, you don't want the service, you want the service to be maintained. It's a question of risk management, and unless you've got environmental monitoring in place, you may not want to take that risk. So, you know, we've done this, for example, the University of Surrey. I think we saved them 20% of their cooling overhead by flooding the data centre with lots of temperature sensors, and therefore every degree centigrade we increase the data centre, we could see, okay, there's a hot spot here. Why is that hot spot there? Well, it's because the cooling needs to be jigged around a little bit, and we did it incrementally by raising the temperature 1 degree at a time.
Did you also factor in? Sorry, I'm going into. I'll let you finish your presentation. And
That's all right. We're still trying to get the rest of the presentation up.
Excuse me, I've got it on this USB now.
No, it's okay. We've got it here.
Oh,
It's
right.
just this thing's now stopped
I was just
responding.
wondering how do you factor in like generator costs and things like that? Costs of providing a generator for, and obviously keeping it topped up with diesel to make sure that
Well,
when it does kick in.
what provided through using the PUE, I provided the facility cost for the facility overhead. So I factored that into my weekly costs. So in effect, yes. And there were things that we kind of could have done better before the project, actually. That was basically not assuming it was going to be easy, because I think we did actually assume that. It is quite difficult. So a lot of what we've learned, if you're going to do this yourself, it would pay you to have a look, see what we did. And really, prototyping it was the best way, because we're getting some information out, seeing what you've got, checking that it's okay, That was probably the best approach we found. And trying to do everything at once, doing it in small bite sizes. You need to actually look at everything that you've got and you're trying to get information from, because every device is different. So you've got to do all that research up front. When you come to actually trying to meter your systems and monitor them afterwards, you'll be prepared for getting the information that you need out of them. You need to issues with kind of not having SNMP information and data is quite tricky, and that took us a lot of time to overcome. So if you know the devices that are not going to be able to give you that information, you can prepare for that beforehand. Spend a little time getting all your MIB files that you need for SNMP, and work out, because some of those devices, they will give you so many values. It's mind-boggling, and you just look through them and you go, I don't even know which of these I actually need. And sometimes you only need like about 2 or 3 of them.
Yeah, network switch can give you, some of them can give you 10,000.
And a lot of them don't make any sense. You look at them and you think, I should be able to see there how many transmitted packets that I've sent. And you look through it and it's got like about 30 different versions of transmit packet. And you think, which one is the one I want? Sometimes you might need to contact the vendors to actually get the information you need. So do all that up front. And audit your data center. Know what's in your data, know where it is. Because then when you come to monitoring it, you know exactly what you're looking at. And if something changes, somebody wants to come along and change something, you know where it's going to impact you. Okay, this is really important. One of the issues we had is when we built the data center, we were quite forward thinking. We thought, well, we're putting IP addressable PDUs into the cabinets, so that if we want to see what power usage is being done at a cabinet level, that'd be great. And if we need to grab that information later and use it in an application, we can do that as well. And then we found out that the PDUs that we bought, instead of being able to look at an individual socket where that a server's plugged into, it can only look at 2 circuits. And if you've got other equipment also plugged into those circuits, then it's a nightmare. So then you've got to say, okay, we've got to change it. So half of this PDU only has 1 server plugged into it, and that's the server we want to monitor. But that's a lot of effort that you've got to go through beforehand. And you can go out there and buy PDUs that actually tell you per socket, and that's much easier, obviously. But that's a lot more expensive, and they cost them about 3 times as much as the other PDUs. So it's going and swapping out your entire PDU estate.
It sounds like there's quite a lot of upfront changes you need to make in order to be able to get the right data.
Yeah, because and if somebody messes that up by coming along and plugging a server into the circuit that you were previously monitoring because it only had 1 server on it, suddenly your numbers are going to jump and you're going to go, what happened there? So we've learned a lesson about going out and buying cheap PDUs. That it's just not worth it. Get things that are a bit more expensive, and it gives you much more flexibility later on.
Of course, it often makes me laugh, because if you look at the cost of doing something like that compared with the cost of the IT infrastructure you put in there, it's kind of in the small percentages, but they always seem to be cut from the budget, when actually it's very important information.
Isn't it called value engineering?
But another thing is, if you haven't got the right PDUs, our PDUs only give us amps. Now, unfortunately, if you're not an electrician, you don't realise what a problem that is. But we want to measure kilowatts. And so to turn amps into kilowatts, you need to know the voltage and you need to know the power factor. And you can't get that from a PDU if it's only giving you amps. So you have to go back to the UPS, and you need to know which phase the cabinet's on, so you can work out what your kilowatt. It starts to get very complicated. So I've got some quite complex equations in just to cover off the fact that I've got a cheap PDU that I'm trying to meter from.
Come on, Steve. Confess. Yeah. Did you specify that PDU, or was it there before you arrived?
They said this is the PDU we picked for you, because it was a design and build contract. And so Future said, this is PDU. And I went, yeah, okay, that looks good. It gives me amps. Because that's what I wanted. I wanted amps. I didn't realise I actually needed kilowatts. So I've learnt that lesson now. So now I buy PDUs that give me kilowatts. So much easier. So during the project, It's really important to keep your stakeholders involved, because if they want to make changes to that service, they want to make changes to the infrastructure of that service or infrastructure of your data centre as a whole, because to support them, then you need to make sure that how that's going to impact what you're doing. And also change management is really important. It's important during the project, it's important after the project. You really need to, so this is where operational processes, it's nothing about the technology. This is about having mature operational processes around it, because if you haven't got those, you can be wasting your time doing this, because it'll be out of date so quickly that it's irrelevant, and all that money you've spent and effort and time is just wasted. And also, you need to work closely with your DCIM vendor, because if you come across an issue, you'll need to get that resolved. You know, like I say, you're trying to do things that perhaps that particular product it couldn't foresee, and so if it can't support that, then you need to get back quickly to them and say, you know, this is the challenge I'm having. Why am I not seeing what I'm expecting to see, and get them to fix it. Okay, so post-project change management again. Check the validity. You know, just because you've done the project, you're now getting this lovely dashboard up. You know, it looks great. Keep an eye on it to make sure it's still giving you the right values. If something goes skew, it could either be that you've got a problem, or that somebody's changed something. One of the two. Keep stakeholders informed again, because of what they want from the system might interfere with what you're trying to do. Going forwards, next time you want to buy something for your data centre, think really carefully about what kind of data you might want to get out. Build that into your procurement processes. Make sure you can get the right kind of information out, so that you're not having to do all this other stuff, all the other challenges that I've had moving forward.
A good example there is actually modern servers. Some servers make you pay for. Some servers will allow you to get the power utilisation directly from the server. Some vendors, you have to buy a software license that costs quite a lot more to go and get that information.
Sneak it out.
HP, sorry.
Yeah, so and when we did this assessment against Just IT's carbon footprinting tool, we found that actually some very small changes could make it much more effective. So, for instance, if you go through the tool, which I've got a link to in my presentation, it suggests what the facility overhead is. Now, if you're measuring your PUE of your data centre, you can use that instead, and that gives you a much closer figure. And also, we also found that we assumed that we knew how much power that our server was going to consume. It's an Oracle server, and we went to the Oracle website. They have a tool. You can plug in what you've bought and how it's configured, and it tells you how much power it's going to consume. Great. Okay, and we plugged all the information in. It said we're going to use about, when it's running, it's going to be using somewhere around 700 watts. Okay? And then what we actually found when we metered it, it was actually using almost twice as much. So that tool was no use whatsoever. So if you were going to be basing some of your future data center requirements on some of the information you're getting back from your vendors, you know, you're going to be making some wrong decisions and perhaps paying more for data center infrastructure than you needed to pay. And what we also did was we added in the carbon cost. So I added, as part of the tool, added in the carbon cost as well, 12 pounds a tonne of carbon, to get a true picture of what the cost would be. Okay, outcomes. Okay, so we've got this. We've got for one particular service, which was the book lending system. We've got complete carbon and power cost, and we know how much it's costing in real time. And because we've developed that model, if you like, we can apply that to other services that are architected in a similar way. We've done the simple one. We're going to do a really difficult one next, the most difficult one we've got, in fact, because this it's all very well choosing an application that exists in one place, but if you've got data center A, data center B, and your service is in here, and your service is in here as well. And because it's a critical service, so it might be the finance system, it could be the student record system, I don't know. And so what you're doing is you're running these in parallel, what's called active-active. So you've got them, both of them up, they're sharing the load. And so if this one goes down, this one takes up the workload. But now you've got to meter that, and you've got to meter that as well. So it's now a lot more complicated. And also the system we're choosing is fully virtualized. So it's running within a virtual machine. You can't just say, oh, we'll just meter the whole server, because there might be 60 other applications on that particular server. So we need to get an individual service within that. So it's going to be a lot more complicated, and we're hoping to, and we will publish the results of that as we get through the project. What we also found was, because we were monitoring the power usage of the server, we were actually able to also determine how effectively we were using that server, and whether there was, in the replacement life cycle, if we wanted to replace that server with another one, we could make a really good assessment actually of whether or not we would be getting a lot of value from doing that, or whether it wasn't worth it. So we also, because we've got the information that costs what to deliver on a day-to-day basis, we can compare that with the cloud. You know, if we go to a cloud provider and say, what does it cost to deliver this particular service, and we get a per day figure, we can look at that in terms of what it costs us to deliver in-house. If you add that into everything that Heidi went through, you'll get a complete picture as well. So you can, hopefully it's a really good complement there. And also, because I was having to talk to all the stakeholders about the fact that we were doing this, because I didn't want them to start changing the infrastructure on me, there's an increased awareness of sustainability, and we've actually included in our project processes now, we've actually said if somebody puts in a new project, they have to state whether or not there's going to be a negative carbon impact. And it gets them thinking about it. And if they tick the box and say yes, and we then go and measure it afterwards, and say that's the idea, and show them, demonstrate to them how well we've done. Yeah. So there's a lot more information in my blog that you can go and take a look at. Right, so this is the interesting bit, because this is what it looks like. Fortunately, it's so small. Okay, so you can see here. I won't write on the screen. No. So this dial here shows us how many kilowatts per hour we're using for our book lending system. So that's about 1.6 kilowatts all in. That tells us how much carbon, 0.9 kilograms of carbon per kilowatt hour, and there's the cost. So it's 16 pence an hour it costs to run that service. And actually we found, I've been watching it obviously since we finished the project, and it varied between 15 pence and 18 pence an hour. So now the really interesting thing here actually is that I was looking at the server loading. So how much the server, because it sits on the server by itself, this was a system that isn't virtualized, I wanted to see how well it's using the server, and it's really low utilization. In fact, so low that that's a bit laughable, really. It shouldn't have its own server at all. But of course, when we spec'd out that system, we went to the vendor and said, what should we be buying? Because it was a replacement for an existing server that we had. And they said, oh, you must buy this type of server, and this has to be this kind of throughput, and blah, 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 blah. So we went out and bought that, and it's too big for the task. So we wasted money on buying far too performant a server. Actually, we could have bought something a lot smaller. So that's why I said it guides us. When we look at our server replacement strategy, we were looking at statistics like this and saying, well, obviously, the next time we need to replace that server, if we still can't run it on any other type of system, we need to get something a little less performant to save ourselves some money. in the
Of course, the
future.
more systems you can compare, the better feeling you can have for what the best value is.
Yeah. So that was really useful. The other thing we've been able to do, which wasn't able to do previously, because I was doing it all manually before I had the DCIM system, was that we can calculate our PUE in real time. So I can actually see directly how well our data centre is working. So particularly because we've got a green data centre, we take advantage of the ambient temperature outside. So I see in winter how well my data centre is performing. And if we've got a fault, like we have a fault, an air conditioning unit fails or something, I see it suddenly spike up or suddenly drop down, and I can investigate that really quickly. And so we can save a lot of money on operational costs within the data centre because I'm looking at the profile and I can see the way it should be behaving, and anything that varies from the norm, then I can jump on. And you can do things like look at temperatures, looking at hotspots and stuff like that. But this is another thing that I did, which was performance per watt per pound. Now I only have one system to compare this with at the moment, and the higher the figure, the more you're making use of your compute, if you like. This is actually quite low. It's very low, but I get a better sense if I have different services, because obviously services that are using. I said that this server is completely underutilised. If I can just compare that same chart with another chart for a system that's using the hardware a lot more efficiently, then I should be able to, effectively, I should be able to make direct comparisons and use that as part of my cost comparisons. And I can actually see here, and there's a little metric, a widget here that tells me how much per month Voyager costs me. So it's costing me £110 per month. Okay. And if I've got a year's worth of data, I can put per year as well. And it's kind of nice just to show you, your CIO, if she wants that information. Okay, so it's just lots of really interesting stuff that you can do, and this is only really touching the tip of the iceberg. This is stuff that I've done, but I'm sure, if you had a particular question that you wanted to get out of the system, you could probably answer that as well.
What's the dashboard built in?
It's our product, so you just configure.
Yeah.
Oh, okay. You configure you say I'm interested in that, and then decide which widget you want. You want a historical graph, you want a
So all this data is being pushed into some kind of data warehouse.
Yes, so again, we build our system. One of the key things that people forget is if you start, so I was at a commercial presentation this morning to a well-known TV company and broadband supplier, and they were talking about one data center where they have 1,200 devices in the data center, and that was a relatively small data center. If you do the calculation, say I want to get one piece of information every 15 seconds, let's say, or every 20 seconds off each of these devices. You do the calculation every year. I think I did the calculation. It was 10 billion data points every year. So you've got to be careful how you store the data. So we have a scalable system which stores the data in a compressive database. So you don't actually store all of that data, but you keep a record without storing all the data. You can't just bung it in SQL. You've got 1.2 billion data sets at the end, data points at the end of the year.
I'm just aware. Can I just take that up with my code after the?
I was really just sort of concerned about the fact that maybe a sort of unfortunate side effect of this type of project is almost your reliance on having a big data tool to be able to manage all of the data that comes out.
Well, actually, it's probably the reverse, because we were doing everything manually, and now I have it presented to me automatically. So I'm finding that I'm doing a lot less data analysis than I did previously, because I'm just looking at what I need.
What we find is that most people have hardly any data, and if they do have data, it's owned by particular people. So often we find, what do you call it, estates people they have some of the data, but they're not very good at sharing it. And then the data center manager has some data, but he doesn't have the data that the estates people have. And then the IT manager has different data, and it's about bringing that data into one point and having a tool that can